Good morning, students. Our today's topic is work. What comes to your mind when you hear the word work? I'm sure it will be homework. But I'm not talking about homework. In day-to-day life, so many people say, I am busy with this work or I am busy with that work. We are going to talk about work. Now, what is work? In physics, how will define work? What is the difference between day-to-day life work and physics work? How we measure work? These things we are going to see one by one. For that, I am using this slide. So when you see carefully, in mechanical situations, energy transferred by a force from one body to another is what we call work done by that force. But in physics, work is said to be done only when body moves under the influence of force. So body has to get a displacement. When we apply force, if body is not getting movement, if body is not getting displacement, then work done is zero. So this is the very important thing. If there is no motion produced in the body, even when force acts on it, the work done is said to be zero. Then when work is said to be done and how we measure that work, how we define work, these things we are going to discuss. Now, so the definition of work is very simple. What is that? Work is said to be done by a force on a body when force displaces the body through a certain distance, either in the direction of force or opposite to the direction of force. So here you people need to keep in your mind is body has to move. Its body has to get displacement. That displacement may be in the direction of force or opposite to the direction of force. Then only we say work is done. Right? Now we'll see how we can measure work. So whatever the work we are doing, that work, how we can measure, that we are going to discuss. To measure work, so first of all we need to see it depends on what. It depends on, as I told, it depends on not only force, it also depends on displacement. Just you are applying force but body is not getting displacement, then work is not done. That's why you people need to keep in mind that work depends on magnitude of force and displacement of the body according to physics. So magnitude of force and displacement of the body, these are the two things which decides the amount of work done. So to measure work, we are using these two only. Let us see how we can discuss about it. Here we are taking one car. Let us assume on that car F amount of force is applied. When F amount of force is applied on the car got displacement in the direction of force. Let the displacement of the car is S. Then we can say that the work done is equal to the product of force F and displacement S. Okay, so what is the work done here? It is the product simply. It is the product of what? Force and displacement. So this is the definition easily you people can keep in your mind. What is that? So work is the product of force and displacement of the body. Is this formula we can use all the time? In all cases? No. So in different cases we are using different formulas. Then when we have to use this formula we have to use only when body gets displacement in the direction of force. Then only we use work as the product of force and displacement. Now we are going to see what is the nature of work, right? Is this the vector quantity or it is a scalar quantity? This we are going to discuss. We know that work depends on force and displacement. Force and displacements are vector quantities. We know they are having magnitude and also direction. That's why they are vector quantities. But so work is not a vector quantity. It is purely a scalar quantity. It is having only magnitude, no direction. And one more interesting thing is work is independent of time. It never depends on time. It depends only on force and displacement. Okay, so to measure work, we are using these units. What are the absolute units? We are going to see absolute units, and even we are going to discuss gravitational units. So first we'll see absolute units used in SI system and in CGS system. In SI system, we take joule as a unit for work. That means by using joule, we measure work. Work is measured in joules. Joule is a scientist's name. On his name, we are taking the work measurement. So how we define joule? That we are going to see. What about CGS system? In CGS system, we use erg. Erg is the CGS unit of work. Now we'll see the definition of joule. So joule means what? How much amount of work we consider as 1 joule. This we will take. Here we are able to see we applied 1 Newton force on the car, and because of that, car got 1 meter displacement. So here definitely work is done, and the amount of work done in this case we call it as 1 joule. When we say the amount of work done is 1 joule, when we apply 1 Newton force and we are giving 1 meter displacement in the direction of force, then we say that work is 1 joule, right? So we can define like this. The work done is said to be 1 joule if 1 Newton force displaces the body through 1 meter in the direction of force. This is how we can define joule. What about erg? Is this the same definition? But we know that in CGS system, force is not measured in newtons. Force is measured in dynes. And displacement is not measured in meter. Displacement is measured in centimeter. That's why we can take like this very simply. When we apply 1 dyne force, if body gets 1 centimeter displacement, then we say the amount of work done is 1 erg. So this is how we are giving definition. The work done is said to be 1 erg if 1 dyne of the force displaces the body through 1 centimeter in the direction of force. What is it? How much force you have to apply? 1 dyne force. How much displacement you have to give? 1 centimeter displacement in the direction of force. Then we say that as 1 erg. The amount of work done in that case, we take it as 1 erg. This is how we can take the units in SI system and in CGS system to measure work. Right? Now we'll see what are the gravitational units. I explained about absolute units. Now we'll see what are the gravitational units. Gravitational units are little different. In SI system, we use kg weight meter as unit of work. Kg weight meter is the SI unit. In the same way, in CGS system, gram weight centimeter is the unit of work. So now we'll see what is the relation between joule and erg. We know length we can measure in meters, length even we can measure in centimeter. There is a relation between meter and centimeter. What is that? 1 meter is equal to 100 centimeter. In the same way, work we can measure in joule, work even we can measure in erg. What is the relation between joule and erg? Right? So we know that 1 joule is equal to 1 Newton into 1 meter. Right? Just now we learned that 1 joule is equal to 1 Newton times of 1 meter. Right? And we already know 1 Newton is equal to 10 power 5 dynes. 1 Newton is how many dynes? 10 power dynes. 10 power 5 dynes. So that we can use here. And we know 1 meter is 100 centimeter. That means 1 meter is 10 power 2 centimeter. So when I substitute these things here, then automatically in the place of 1 Newton, I substituted 10 power 5 die. In the place of 1 meter, I substituted 10 power 2 die. And because of that, I got 1 joule is equal to 10 power 7 dyne centimeter. So this is the relation. You can also say 1 joule is equal to 10 power 7 erg. Why? You know that 1 erg is 1 dyne into 1 centimeter. Therefore, I can say 1 joule is equal to 10 power 7 x. So this is how we can take the relation between joule and erg. I will stop here. We will see in the next class. Thank you.